Okay, so yeah, we okay, so we are going to learn how to draw the ray diagram. So no need calculator. Just need pencil and ruler. Okay, just need pencil and ruler. Ah, yeah, please. Who is it? VSE. Shadow. Oh, please send this link to the class group. But I think I forgot to send the link. The link always the same. Okay, the link always the same. Because I feel it's a long chapter, so today content is quite compact, lah. Right? So you need pencil and ruler. And here, this is, I typed something wrong. The way to draw mirror is correct it. Okay, we turn to page 2 first. This is page 1. This is page 2. Page 2. Okay, so it's the way to draw lenses first. The way to draw lenses first. Okay, how to draw a lenses and how to identify the lens. Okay, first of all, we look at convex lens and concave lens. Many people will confuse how to identify. It's actually concave. Cave means 洞穴这样卦 cave is 卦 means what? 卦 means the space is empty inside. Okay, so this is how let's see concave. Can you see the cave here? Now this is concave lens, this is convex lens. Convex lens means both sides pop up together. And yeah, okay, both sides pop up together. Then this one is both sides inwards together. Okay, then what's the difference between convex and concave lens? It's like this. The light for convex lens, the light will converge and focus at one point. Converge means cover, they close up lah, focus lah, right? Then, and focus at one point. So this is convex lens. Okay, so converge. So how to remember it? This is convex, convex, converge, convex line, converge like con. So this is concave lens. Concave, it will diverge the Okay. So means the light will be diverge out lah. So it will be distract out lah. Okay, now how to draw a lenses? Okay, first of all, draw principal axis. What is parenthesis? It is an imaginary line that passes through the center of the lens. Okay, 接吻你的眼睛。Okay, so this is a lens. Okay, then where is the line? The line is imaginary line that goes through the center of the lens, right? Goes through the center of the lens. So this line called principal axis. Here, principal axis. So second, draw the pole line. Pole line means the center is perpendicular. Perpendicular means 90 degrees to the principal axis here. Then we draw the focus point F and 2F in equal distance. Finally, complete the lenses. Okay, so how to draw it? See, I already draw the principal axis, and here is the pole. Okay, so now normally how we draw the convex lens, we draw like this from the center, from the edge from one edge to another edge. Okay, how we draw concave lens? Normally we draw a horizontal line first, then we make the curve inside. We make the curve inside. Okay. Then I find out that this is hard because the curve line is hard for us. It's without using the helps of ruler, it's hard. So actually, there are second way to draw convex lens and concave lens easier. So this is easier way. Okay. So for convex lens, we just draw a bracket close the pole. Remember, this is a pole. This is the principal axis, principal pole axis. So for concave lens, you just need to draw the open bracket. This one close bracket, this one open bracket. Can you see that actually if you fill them up, it's like this. If so, actually you no need draw this, but with these two close brackets, you can imagine that actually they close up as a convex. Then this one you curve up as a concave. Okay, so convex close bracket, concave open bracket, so that you can imagine that. All right. So this way is easier lah. I don't like to draw this too because sometimes my hand jab also cut and draw. I like to use the easier ways. Then don't forget, use your. This is just we need to draw the F and 2F. Please use your ruler, measure any two distance as long as equal. For example, you measure 2 cm here, there you write F. You measure another 2 cm or 4 cm from the pole, from the center, you write 2F. Equal distance, yeah? Equidistance, right? So since if here you draw 2 cm, Here you must draw 2 cm to use ruler, alright? Then, this part not long enough, huh? Please extend it. Not extend, extrapolate. Then you add 2x. This one, same thing. You can draw 2 cm or you want to use 1 cm. So this is F and this is 2. This is S and this is 2. Okay, so same thing as here. This is S, equal distance, yeah. Use ruler, measure equal distance, yeah. This is 2F. So equals, okay, see, I never use ruler, so it's like not equal distance. From here to here, S, then to here to here, S, and 2. Okay, so S and 2, S and 2. Measure properly, yeah. Okay, so now, what is the difference if you make your F shorter and you make your F longer? So here is the result. This one is short focal length, so high power of convex lens. So we can say this is short focus length. So high power of convex lens. Then, okay, you might not know apa ini, never mind. You just remember the relationship first. Okay, then this is long focus length. So this is low power of the lens. Okay, short focus length means what? Means after the light travel, it will focus in shorter length. And this one, after the light travel through the lens, it will focus in longer distance. Okay, so normally we say what? We say this is thick. This is thick lens. So short focal length. Then if this is a thin lens, then it will have long focal length. Okay, then here you write power of lens. Power of lens is equals to 1 over focal length in meter. Apa ini means power is inversely proportional to F. Power is inversely proportional to F. Okay, so now, do you notice that when you, I believe that all of you have experience on checking eyes, right? So normally the optometrist, they will say, your power become higher. What does it mean? Your eye power become higher means your focal length becomes shorter. Means the longer distance you cannot see properly. So that's why you need the spec to help you correct your eyesight. Okay, means your, so we learn this in Form 3. It is long-sightedness or short-sightedness depends on the shape of eyeball and also the size of eye lens. All right. So now here, same thing. So we can get a conclusion. If it is a thin lens, then it will be long focal length. Then it will be low power convex lens. So thick lens, short focal length, high power of lens. Okay, today we don't calculate anything, just theory and rate and memory. Okay, then do you remember what is the name of this line? It's a must to know. If not, when I say, look at the principal axis, they say, mana ada? Mana ada? The principal axis is this imaginary line that goes through the center of the lens. What is pole? Pole actually is the center of the lens, which is perpendicular to the principal axis. Right? Now here. It's a must to remember, if not, I will explain to you. Not hard to explain to you. You not understand what am I talking about. Okay, principal axis means the horizontal line. Okay, so now this is for convex lens, and here is for the concave lens. Okay, so same thing, we draw what? We draw principal axis first, then we draw the pole, then we complete the lens, and then you can see that since this line is convex means converge. Converge means they kumpulkan, they focus lah. But concave lens, they diverge. Concave diverge. Now this is how I differentiate the shape and the light lah. Convex, C-O-M-V, C-O-M-V. Alright. Concave diverge. Diverge means the light become dispersed out. Okay. So what is the focus so this is the focus we draw. Then this focus is before. Normally we draw the point with capital letter and the length as small letter. Okay, this one we always learn in maths. For example, they always say, here is A, B, C, capital letter. Then this length, we say this is X, Y, Z, the length. And then the angle, normally we also use small letter, for example, P, Q, R. Okay, on the point, normally we use capital letter, and the length is small letter. So again, okay, so now we will use this point as the reference point and then diverge out the line. Okay, the same thing as here. This is thin lens. Okay, sorry, not the same thing. Now it's different. Okay, thin lens is high power. Thin lens means short focal length. Short focal length. But for this one, thick lens is long focal length. So this is low power, the opposite. Okay, the opposite. And normally, this F is after. For convex lens, this is the light before the lens. This is the light after the lens. Okay, so here, this is before the lens, and this is after the lens. Okay, so when we use the focal length after the lens is positive f. Then if this is the length before the focal length, normally we say it is powers of 1 over negative f. Okay, negative. So powers is inversely proportional to 1 over negative f. Positive because we use the focal point after the lens. Negative because we use the focal length before the length. Okay. Hi, Carho. Hello. It's okay, I record already. If you cannot make it now, cannot make class now later. Hi, Carho. Okay. If you cannot make class now, I record already, will upload in YouTube. Okay, no problem. Don't worry. Okay, so now sure, can send the recording to 4SA group. Can. I will upload to YouTube. Then anyone can see, no problem. As I told my class before, the exam is 2 months earlier, so I scared. I'm not sure. From 5, 2 months earlier, from 4, not sure. In case I cannot finish, we cannot finish, so I make class earlier. This is the last part for chapter 6. No problem. Okay, if anyone you're not free, can do your things first. Sorry, I got it recorded. And anything you still not understand, can see me or see Viva in school. And your practicum teacher, alright? No problem, it's okay. Oh, no problem. I got recording. Don't worry. I have to upload YouTube and you can check. Anything still not understand, can see me in school. Okay, so now guideline to draw the ray diagram KFC. We look at this KFC. No. KFC. Can you see KFC? Next page. Yeah, next page. KFC. Okay, first of all, we look at convex lens. Then we see apa itu KFC. Actually, C refers to center. What is F? F refers to focus point. K means kotak. Okay, KFC got kotak, right? KFC, kotak focus point center. KFC. Alright, so now we look at C first. We look at convex lens first. And why convex lens? Because convex lens actually is magnifying glasses, Pangati. Okay. Okay, so now this is the center. The ray pass through the optical center means is the line intersect from the pole to the principal axis. Here is the center. So when the light pass through the center, it will not refract, so directly go down. Just one line go down. If the light strike on the center, it will just go down. Now, this is called KF. Here is K, here is F. Okay, when the light ray parallel to the principal axis, this is principal axis parallel, and then pass through the lens, it will be refracted, means bend. Refracted means bend. 那折射，它会折射 bend towards the focus. Okay, F. So remember just now I said this is kotak. So here, when the light ray parallel to the principal axis, see, it's like a kotak. Okay, it's like a kotak. So KFC. Okay, so I will call it a K. Actually, there are many ways to remember, memorize. Another way is to use some sentence to remember. But sorry, I am not good on that. So I would like to use ray diagram. YouTube channel name, Jenkuser, me. Now later after I upload the link for you. Actually, this one last year also I did, but this year I feel I make the module better. Last year I also did this for your Form 5 series. Form 4 last year got enough time. This year, I better start early. Alright, so now a ray through the focal point. When the ray goes through the focal point before the lens, okay, it will be refracted, means bend parallel to the principal axis. So this is called FK. FK. C, KF, so KFC or FKC. Okay, so here are the three principles which the light passes through the convex lens. Then this KFC can be applied for all lenses and mirror. KFC, FKC. Okay, so when we want to draw how is the image formed, then it will based on the KFC lah. Okay, now concave lens, also the same thing. When the light ray passes through the center is C. Center is here, C. Center of the lens is in the center of the lens. Yeah, same thing, it will go straight. It won't bend. Without refraction, refract means bending, 折射, 折, 它不会折的, go straight on. Right, so next one, when the ray parallel to the principal axis appears refracted outwards. Kotak is the light. Kotak is the light ray parallel to the principal axis. Okay, actually, when we shine the light, when we shine the light, okay, actually there are many lights, there are much light that goes through the lens, okay, goes through the lens. That one lens. It goes through the lens. I forgot to bring my magnifying glasses. Okay, just Just want to show you when the light pass through, the lens, there are many lights, there are much light, many light rays. I switch off first. There are many rays pass through the lens altogether. Okay, altogether. Just that when it passes through the center, it will go straight. Okay. Then for the parallel one, for the K is this. The light that parallel to the principal axis, when it passes through the lens, for convex lens, it will converge to KF. But for concave lens, it will diverge to KF. But this F will refer to the F before the lens. This is normally we will draw in physics, in science, we will draw everything before on the left, and after will be the. For example, last year we learned transformer, right? This is input and this is output. So here input means before primary, then this is after secondary. Input, output. So on the paper, we always draw before on the left, after on the right. Alright, so now the ray that appears to go through the focus point. Okay, so if the ray directly strikes towards the F after the lens, then it will be bent, it will be refracted parallel to the principal axis, or we can say it is FK. Actually, this is C, go straight. KF means parallel focus. FK, focus parallel. Alright? Okay, seems like you understand seems. It's okay, we will draw the complete one. Now this is mirror, we ignore first. Now please look at this page. Look at this page, got many kotak. Okay, so before we start, so let's make a revision first. Okay, so the light, actually there are a lot of light rays that pass through the lens, but we just count 3, KF, KFC, or FKC. Actually, you just need to draw 2. KFC can done most of the ray diagram. Okay, so now let's see. So see KFC parallel to the principal axis, then to the focus. Directly to the center, to the focus first, then parallel. Parallel means the K. Okay, again, parallel, the light ray that parallel to the principal axis, we call it as K. Okay, so now concave lens like this, convex lens like this. Easier way. Okay, so if the bracket is closed, we can make it as a convex lens. If the bracket open, we can make it as concave lens. Okay, that's why we can draw the simple way. So, okay, now we need to know what is U. U means object distance. Then what is V? V means image distance. Okay, and F is focal length. See, all are small letter means all of them are length. Okay, then I might mistake the U for initial velocity. You are not mistaken. You are right. But I tell you, because alphabet only got 26, so sometimes they repeat. Not sometimes. Most of the time they repeat. Yes. Okay, so what is actually object distance? It is an object, then the distance to the center of the lens. Now, this is a concave lens. How to draw a concave lens? Please draw this. Here, you can see the pole I draw here. I draw a pole here. Now, how to draw the lens? Yes, just draw the open bracket. Yes. Okay, so now we put an object in front of the lens. We put an object in front of the lens. So here, this one, from the object to the pole is called U. Object distance means object distance from the center. Oh, from the center. Yeah, here is the center. Then when there's object, sure, there is image. Where is the image? That you might not show up by the image. Okay, never mind, we will get the diagram first. This is last time your senior did experiment. Okay. Last time actually physics lab is in bio lab. So actually you can see that this is bio lab experiment. Okay. Okay, so we look at this image. So obviously, anyone can tell me where's the object? Yeah, object actually is the car. The real object is the car. These two cars. Okay, these two cars are object. Means what? Means the distance from this object to the center. This is the center, the pole, the center. So the distance here is u. Okay, then what can you see now? We compare this car, and so this car you see on the lens, this is called image. Now, can you please compare what is the size of object and the size of image? Which one is bigger? Yeah, okay, object 1 foot. Object is bigger. Any other? I like interaction. Thank you, Cindy. Yeah, actually, its object is bigger, of course. The car so big, the lens is this small. But why we still can see the whole car? We still can see the whole car in the lens so small. And that's because the size of image shrink. So we call it as the image is diminished. We use the word diminish, becomes smaller. Diminish means becomes smaller. It's okay, later we will use this word for many times. Okay, so now I just want you to understand what is object, what is image. Now can understand object and image. Of course, when we draw a ray diagram, we can't draw the whole car. Okay, so most of the time we use object as an arrow. That's already drawn in your module, this paper. Okay, so this is the object. So normally we have brought here that this is object. Or when you just draw U means it's object distance from the center. Now center is the center of the lens. The center of the lens here. Center of the lens. Okay, so now how to determine where is the image? So first, I would use a purple line to draw KF. Okay, so you can just use normal pencil. Okay, this one actually the tip is on the line, the second grid. Here go. Okay, so you draw a line that horizontal to the principal axis. So this is K. Please draw to the pole. Means what? Draw an arrow. Actually means now you are drawing a line. Let's say come from the light bulb to the headlamp to here. So actually you are drawing a line like this. Okay, you're drawing a line like this. Then when it reaches the lens, where will it go? It will go through the focus. Since this is K, then F. But question, which F I should use? The front one, the before one, or the back one, the after? The before or the after? If you're not sure, please check back just now. Please check back the notes just now. Which F I should use? Should be the before one or the after. Darren, thank you. Before one, after one, what else? Okay, where are others? This is a concave lens. Can you look at concave lens and tell me? Now, the after change to before. Very good. Yeah, for concave lens, we use before. So use your ruler. Okay, F. So use your ruler from this point. Then you refer to the F before. You draw a line. This line is normally is dotted line. Use ruler. Then you use this angle. The light ray will be refracted out. So this is KF. Well, okay, so KF done. Then what should we do the next? C. Yep. Means the light directly goes through the C. Please use ruler. The light from the tip of the object directly goes through the C. Okay, directly goes through the C. Directly goes through the C. Then what will happen next? When the light passes through C, please draw arrow. When the light passes through C, what will happen next? When the light passes through C, what will happen next? Yeah, follow through, just goes through. Just follow through. Just goes down. It doesn't bend, it doesn't reflect. It doesn't refract. Just go straight down. Use ruler, yeah. Okay. And don't forget to add your arrow. K, F, and C. There are two lines. And where is the image? So actually, C is what? C is the light. Just now I said the light from here. So here is the center. The light comes from the center and goes. Okay, now we are drawing this object image. How to form this image? We use KFC. Okay, so now where is the image? Image is here. The intersection of purple line to orange line means the intersection of KF and C here. So we draw the image here. On the tip of the intersection point, then your image must touch on the principal axis. So this is your image. Then you can draw here, this is B. Means what? Means this is image distance to the center of the lens. Hey, Darren, you are right. Yes, very good. So now let's draw. Okay, let's write here characteristic. Characteristic. What is the of image? Of image. I write characteristic of image. If possible, here we use the pen. Drawing, we use pencil, but here we draw. Okay, so normally we say three characteristics. 1, 2, 3. which we already learned in Form 1, but I believe most of you forget. Okay, so first of all, we will look at the direction. If both of them on the same direction, okay, see, the light come from the tip. So when these two light intersect, 交叉 intersect, okay, this point would be the tip. Tip 就是尖尖的。Okay, so now we look at it. If the direction is the same, means they are upright. This image is upright. This image is upright. Then we look at this. So since it is upright, means this image is virtual. Okay, never mind, you write this. Virtual. Then the third is look at the size. The size is smaller, but we don't say it's smaller size, we say diminish. Diminish. The size smaller, size shrink. Don't use other word, we use the word diminish. Okay, you might ask, apa itu virtual? Okay, actually, the meaning of virtual is, if you check out the formula list I gave to you, virtual means cannot form on the screen. Maybe you write here. You write here virtual image. Means it is an image. The image cannot form on the screen. And what is a real image? Real image means the image can form on the screen. Then you might ask, apa itu? Okay, now very easy. You look at mirror. You see your image right in the mirror. But your image in the mirror cannot form on the whiteboard, cannot form by projector. You cannot transform it on the screen. That's virtual. Then real means the image can form on the screen. Okay. Okay. Okay, this is a screen. This is a screen. This is a screen. Means a board like anything like solid like. For example, this paper can be a screen too. Then, can you see this red dot? Actually, what is this red dot? This red dot is actually the light bulb. I didn't take Bamba here. This is a light bulb. This is a light bulb. So the light goes through here and goes through. Okay, so means what? Means this is an image. This is a real image can form on the screen. This is an image California from the school. Then, never mind, now you just, if you are not sure, doesn't matter, you just remember when the image is upright, it's virtual, it's not real. Okay? Like the image in the mirror cannot form on the screen. 你照镜子，镜子里面的你不能够被 post 出来放在 screen 上面咯。但是 projector 可以咯。Never mind, you just remember upright is virtual first. Okay? Never mind. Now, let's look at convex lens. How to draw a convex lens? We'll draw first. How to draw a convex lens? Bracket inwards. Like this one. Bracket inwards. Oh, you meant that. Okay. No. Okay, like this. So actually, next we are going to draw a few convex lens, right? Right, all of this. All of this. Please complete all of the convex lens. Number 1, number 2, number 3, number 4, number 5, number 6. All are convex lens. Why there are 6? Because convex lens, they use the F after the lens. So there are a lot of image form. But for concave lens, only one image, one type of image. One type. But for convex lens, there are 6 types of image. That's why I draw 6. There are 6. But concave, only one. Lens. Alright, so type 1 is when object is less than focal length. So you can see object distance less than focal length. So this is object distance U. This is focal length F. Okay. U smaller than F. What will happen? Okay, so same thing, I draw with purple, then I draw with orange. I think I use green and orange. It's easier to see. So first of all, what should you draw? K. Yeah, now use ruler. Use ruler K. Draw a pair. K means parallel line to the principal axis. K, then F. F means after the lens. The F after the lens. Now use ruler. Use ruler. KF. Then where's C? C means the center of the lens. Here. The center of the lens. means use ruler, directly draw a line, goes through the C and follow through. Then you will find out they diverge. They do not intersect. Remember just now how we draw image? They intersect. But now they're not. So what should you do? Extrapolate back this orange line. Extrapolate. Use ruler, extrapolate. Make sure you use this line and you extrapolate. I don't have ruler. Then you extrapolate the green line. Use ruler, extrapolate the green line. And now, ta-da! We have the intersection point of orange and green here. For mine, I do not use ruler, that is one here. Always connect back to the principal axis. So this is image. And so image means here to here is P. From image to the lens is P. Yes, very good. Okay, so now let's write the characteristic of the image 1, 2, 3. So 1, 2, 3. So first of all, it is upright or inverted. Upright means same direction. Yes, upright. Both object and image same direction means upright. Okay. Then, since upright, it is virtual. Now, how about the size? Image is bigger or smaller than the object? Image is bigger or smaller than the object. This is image. This is object. Which one bigger? Image bigger. Means now the image is magnified. 放大了 Magnified. So actually it's like this. So actually you can see the car tire down, then this one is top. So this is going up, this way going up. So image also this way going up. Means both of them upright. This is upright. Then since upright, this is virtual. Means this image cannot post on the screen. But this is object, this is image. Now what's happening? 1, 2, 3. So the size actually is diminished. For this case, okay, for this case, this is a convex lens. Alright, so now continue with, see, we put the object from less than f on the f equals to f on the f in between f and 2f in between f and 2f close to F, more than 2F, from infinity means from very far away. Far away. Okay, so this is how so when the object put in different places, then it will form different image. But the good news is everything just draw KFC. Okay, let's draw KFC together. Don't care about the characteristic first. Now, so this one we draw K. How to draw K? You draw this. Number 2, how to draw K? Parallel, by diagonal. Okay, K. 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 Then F. This F is after the length. So okay, F. This ruler, F. And C, orange. C is here. C. This is 1F, this is 2F. F means 1F. Then you will find out I draw something not nice here. Then you'll find out actually these two lines are like parallel, correct? Yes. You find out they cannot intersect, right? It's okay. Make them intersect. And not make them intersect. We extrapolate it. We extrapolate. We extrapolate. Then when you extrapolate, you'll find out they still cannot intersect. So our means the image will form an infinity. Means that this is the image blur. Okay. Now we don't care about the characteristic. Let's now look at this. How to draw it. KFC like hungry. Oh. Hey, here's rubber. F. C. And you will find out that 不是要请你看先 intersection, correct? Vertical intersection. Okay, so you will find out that where is the intersection point? Intersecting point is here, right? Blue, sorry, green and orange. This is intersecting point. But let me ask you a question, KFC. This light come from where? The tip. This light comes from the tip. So here will be the tip. Here will be the tip, then connect back to the principal axis. The light, see the light intersect from object to image. So now can you see your image is terbalik. Terbalik means what? Means number one, inverted. Inverted means what? Inverted means it's a real image. Number three, what is the size? This is object. This is image. What is the size? Nè, 没有画准，没有对准来画，不可以这样的，要对准来画。Okay, so see here, this one, what's the mistake here is, you can see that actually the F is here, this dot. Okay, but you do not put your ruler properly. Can you see the small triangle here? And that's wrong. Then you will make your image become wrong. Don't make the small triangle. You must go through the line properly. Yeah, if you go through the line properly, the point properly, this is what kind this is green. Go through the point properly. Okay, then orange. And from tip to the so you will see your image actually is here. Your image actually is behind 2F. Can you see? Your image is behind 2F. Why the distance? Why the drawing must be very accurate? Because you just the difference, the angle different for 1 degree, it will change the results. Yes. Yeah, like that. Yes. Actually, it's behind 2F. Actually, it's here on this line. Okay, see? The light comes from the tip. So ends up when the light intersect, here is the tip. So now you can compare to the size. For every object, I purposely make it as 1.5 grid. 1.5 grid. So now I look at the size. Obviously, it's more than 1.5 already. So this one, the characteristic is called magnified. It's called magnified. Alright. So be careful, don't make the mistake. Must be exactly goes through the dot. Cannot be a triangle there. Very good. Wrong example now. Very good. Alright, so now this is magnified. And actually here is U. This is U. And this is V. And actually U also affects, U and V affect the size. You can see U is 1, 2, 3, 4, 5.5, 5.5 unit. Then the U will be 1, 2, 3, 4, 5, 6 point around 7. So if U longer means the object larger, which one longer, the object will be larger. So both of them also equalize in ratio. Okay, so now next here, U equals to 2F. Like KFC. Write yourself. This is object. Like KFC drawings. Mm. Mm. Why else? Then what? Then why? The it's okay. Normal. It's normal for beginner. It's normal for the beginner. Let's see, this one actually should be K, okay, but here, can you see? Must be X like that. F. Start from here, this point to the. Yes, a little bit different. You cannot understand anything. Okay, then the next would be orange F. Can you see? Actually, they intersect on the 2F. They intersect on the 2. Means what? When it is 2F, object on 2F, this is U, and this is V. Means 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. the equidistance, so they equals. There, intersect with it. There. Okay. And if you cannot make it on 2F, also make it on 2F. Beginner, never mind. You also make it at 2F. So 2F, same size, so correct? So now here you are. So here, this one would be upright or inverted. Right. Sorry, it's okay, save this. Okay, so it's like this. Actually, it's inverted. They are opposite direction. It's inverted. Not right, inverted. Then, since it's inverted, then it's real. What's the size? Same size. Right, same size. And it's on 2F, same size. Then, views bigger than 2F is anything else I can see? F is the second line. I think I need something. The second line. Great. Something. Great. Something like this. Something like this. So you will get your image from here less than 2F. So here is U more than 2F. So your V will be less than 2. So number one is they are inverted. Number two, inverted means real. Number three, how about the size? 大还是小？表变小还是变大？原本是 one and a half，这个变成你自己看，这个变成 one。So actually it becomes smaller. Originally 1.5 and this one become 1, so it is diminish, diminish, diminish. Okay, before this we always draw Pepsi. Sorry, I'm at 30, give me 5 more minutes. Now we are going to use FKC. Okay. We can draw the C. C is goes through here. Okay, draw like that. Draw 3 grid like this. Draw C like this. Draw C like this. Okay, draw C. Draw C like this. Okay, draw C. C F F C F F F. KFC and CFK. CFK. So this one we use CFK. This is KFC. Then we got it. CFK. Okay, how? Let's use green. Okay, goes through the alpha. Goes through, parallel to the C. So it's like this. See? Just now I draw 3 grid. So 3 grid parallel. Goes through F. Parallel goes through F after so this is F right. So next is K after that like this. So you will see the image form on the F. After the lens, this is lens. After the lens become K. K means parallel to the principal axis. Then the image form on orange and green, intersection of orange and green line. Okay, so now this image is obviously inverted. Number one inverted. Since it's inverted, it's real. Okay, then the size should diminish. Because the object from infinity is very far, so the image will be smaller. So today, what we have learned, we learned how to draw a concave lens and convex lens. What is UVF? Alright. Then what is virtual image? Image cannot form on the screen. Real image can form on the screen. Then actually everything we draw KFC besides except one. The object comes from infinity, we use symbolic KFC, we use CFG. CKFC, CFG. Only this we use CFG. Then if you draw properly equal distance, then you can get the characteristic of the image in very exact way, like you no need memorize. So, for example, this is SUM 2011 question 25. Next page. Next page. This is an object placed in front of the convex lens object. What are the characteristics of the image form? Like, draw what? KFC. Like, draw KFC. Then you will get something like this. Actually, you can see they are closing. So you just extend them, extend them, extend them. Extend them. Extend them, extend them. No, use ruler, extend, extrapolate them. Then you will find out very far away. Yeah, continue, extrapolate. Yeah, continue until they intersect. Yeah, continue until they intersect. Very far. Then you will find out. So actually, what is here? 不是 This is tip. This is the tip of the object. This is the base of the object. The base of object and image always stick to the principal axis. So it's like this. This is the base and this is the tip. The base of object and the base of the image. This is image. Always stick to the principal axis. Then the tip started with two lines. The ray diagram meets and will close on the ray diagram here. So obviously we can look at its invertible. So C impossible already. Now enter it. Gia Chang,你看到我加强 extrapolate the principal. 不，快点画下去，快点画下去。And tell me answer. Answer. Diminish, same size, or enlarge. Since all of them are the Thank you, Darren. Image is this size. We look at, sorry, object is this size. Image is this size. Image. So it's K equals to PA prime over PA. Means of image, the height of image divided by the height of object. So this, let's say this is 2, this is 1. 2 divided by 1 becomes 2. 2 means what? Enlarge. Okay? Oh, no problem. So we compare the image to original. Image bigger than original. Okay, okay, so that's all for today's lesson. The rest if you want, we can do this. This is mirror. The rest we continue next week. Okay, that's all for today. Thank you, class. Bye. Thank you.